Hello, this is Mr. Rios, and welcome to Chapter 3, Section 2, Solving Inequalities Using Addition or Subtraction. I apologize for my voice. It is a little weak from the previous football game, so just bear with me, please. However, in this section, we will learn to use addition or subtraction to solve inequalities. So what is an inequality? An inequality is a mathematical sentence that uses an inequality symbol to compare values of two expressions. You can use a number line to visually represent the solutions of an inequality. These are kind of like equations, except with equations we always use an equal bar. However, with inequalities we will use inequality symbols. Equations usually only had one answer that made the equation true. However, you'll find that with inequalities we will have more than one answer, which is why we use a number line to visually show the countless number of answers there are. So just a few, actually these are all the inequality signs and the graphs of some examples. So I have here x is less than 3. So we would use the less than sign, x is less than 3. And on a graph, to show the graph of this, we would show the less than sign by drawing an open circle. And then we would draw an arrow pointing to where all the solutions lie for this equation. I'm sorry, for this inequality. So this means that all the answers that are less than the number 3 make this inequality true. So the number 2 would make this true. The number 1 would. So we would draw an arrow going that way in a number line. For the second example here, x is greater than negative 2. So negative 2 on a number line, obviously negative 1 would be here, 0 would be here. But the way we can graphically show this is we use an open circle for just the normal less than or greater than sign. So an open circle on negative 2. And I'm going to draw an arrow showing where all these solutions lie. This says x is greater than negative 2. So all the numbers bigger than negative 2 is the direction our arrow will head towards. For the next example, x is less than or equal to 0. Now, and I should have had a 0 here, but this means that x is less than 0, but it can also equal 0. That's why we have or equal. So it's going to be less than or equal to 0. For the or equal inequality symbols, we're going to draw a closed circle, meaning that this number is also included. 0 is also included with our solutions. And we will draw our arrow towards the direction of our solutions. Since x is less than or equal to 0, we will draw our arrow to the left towards the negative numbers. For the last example here, x is greater than or equal to 1. We will draw a closed circle on the number 1. And I will fill in the arrow to the direction of x being greater than 1. So all the numbers that are greater than 1 is the direction our arrow goes. Now, here's the key for 8th graders, is understanding that with the normal less than and greater than signs, we used open circles for their graphs, meaning that number is not included. For the less than or equal, we used closed circles. So less than or equal, greater than or equal, we use those closed circles when showing the graphs. When we're solving inequalities, the properties of addition and subtraction that exist for equations are mirrored for inequalities, meaning they're the same. This means we may still use inverse operations of addition and subtraction to help us solve inequalities. The only difference being we no longer have an equal sign, we have an inequality sign. So let's take a look at a quick example. Solve the inequality, graph your solutions. So we're going to solve for x or isolate x. We're going to treat this just like an equation, only we're going to be mindful that this is a greater than sign. So x minus 4 is greater than 7. I'm going to do the opposite of subtraction, which is addition. So I'm going to add 4 to both sides. Bring my inequality symbol down. I'm left with x on the left, and on the right, 7 plus 4 is 11. My variable is isolated, just like with equations. I am finished. And this means that all the solutions, all the answers are greater than 11. So on my number line, I can list 11. It is great practice to make sure you list the numbers directly to the left and right. That way you know exactly where you are on the number line. And we want to show that all the answers to this inequality, meaning all the numbers that are greater than 11. So open circle on 11 because it is just a greater than sign. And my arrow will be heading towards the direction of all the numbers that are greater than 11. And that's it. We're still using the same properties of addition and subtraction that we did with equations, except now we just have an inequality symbol there, and we have to be mindful on what that means, meaning there are more than just one answer that make this inequality true. So here's your first you-try problem. Solve it and graph your solutions. Also fill out the Google form below. You will not be able to graph your solution in the form below, but I do want you, to the best of your ability, to type in your answer. And you can simply do that by saying in is greater than. You can use words and your value there. And of course, we always have word problems. That's what the real world is about. So for this example, your goal is to take at least 10,000 steps per day. According to your pedometer, you have walked 5,274 steps. Write and solve an inequality to show the different numbers of steps you can take to reach your goal. So right here, I'm going to try and focus on some key words here. We have the word at least, or the word phrase at least. That's going to mean, and we're talking about 10,000, at least 10,000. So if I have 10,000 here, at least means that I have to be bigger than 10,000. So at least also means that it's going to be or equal, because at least 10,000 could be 10,000 or anything bigger than 10,000. So after that, I have to kind of take in some of the other information here. I've already walked 5,274 steps, so I can go ahead and include that. Now the directions say write and solve an inequality, show the different numbers of steps you can take to reach your goal. So the idea is we've already taken this many steps. How many more steps do we need to take to be able to reach at least 10,000? So we've just set this up. We'll solve for our variable, and then we will graph it. Instead of adding 5,274, I'm going to do the inverse and subtract 5,274 from both sides. And bring my inequality symbol down. On the left, I will have 4,726. And on the right, I'll be left with plain old boring X. So the number line here, I would find where 4726 is located. I'm going to go ahead and put its neighbors, 4725 and 4724. I'm sorry, 4727. Now, what kind of circle goes on our number here, 4,726? It's going to have to be a closed circle because this is less than or equal. That or equal bar right here always means closed circle. Which direction are we going to go? Well, we're saying that x is greater than this number, so it has to be all the numbers to the right. So here's your second and final you-try problem. Copy this down in your notes and make sure you record your answer in the Google form below.